This is Law of Conservation Energy video part 2. This is starting with your student note sheet on question number 9. Here we're going to talk about the concept of delta H, which is this symbol here. Delta is this little triangle. It is the Greek letter D, delta, and it always stands for change in. So as you move to Physics 11, you will see delta V, which would be change in velocity, or delta T, which is change in time. Today we're talking delta H, which is change in height, which can be measured in meters. So our example over here, I have my roller coaster, and it's going to start up here at my 90-meter mark, but the place I want to actually measure its final velocity is over here at 50 meters. So this is our change in meters. It's a drop, and we started at 90, we went down to 50, so this is a drop of 40 meters. Okay, that's going to be what's going to function for our height. Most of our questions up till now, it's asked you to find the velocity at the bottom, and you've used the entire 90 meters of height. But this time we're going to say we're not stopping at the bottom or calculating at the bottom. We're going to let the roller coaster go back up the hill and find out how fast it's going at 50 meters. Okay, so to do that, the first thing we do is calculate our change in height, which is 40 meters. Which is right here, 40 meters. And we're going to follow the same type of equation. Loss of potential is gain of kinetic, and we can solve for velocity. So here we have get out your fancy algebra skills, cancel your masses. Okay, so that's the first thing. We don't have a mass in this question. So I have an m on both sides of my equation. I can take it out. Now I'm going to fill in what I know. Gravity is 9.8, and my height was 40 meters. That's how much I dropped. In Physics 11, you'll start talking about putting a negative in there because it's going down. And then 1/2 velocity squared. And I don't know my velocity, so I'm leaving it as v. Now, in order to do my calculations, I would do first 9.8 times 40, which is 392, equals 1/2 v squared. My next algebra step would be to take my 2 up here and do the opposite. So I'm going to multiply that number by 2 to cancel it over here. So here's my 784 would equal v squared, because that removes my 1/2. And the next step, it's a squared, so we're going to take our square root so that our number's not so big and awkward. 28 meters per second is my velocity at the top of the 50-meter hill. And my very last example I want to do is a moving right into Physics 11, but I'm sure some of you are up to the challenge. This is one where all 4 of your terms have numbers and no zeros are present. So you're going to have a little bit more math going on here. So I'm going to go back to our very first equation where we had the 4 terms. Potential initial, kinetic initial equals potential final, kinetic final. And in this case, we're not going to cancel any of them. We're just going to fill in all our numbers. So it's really important to keep your math in a nice vertical row so that you can line up all of your symbols. First, we're going to cancel our masses. So mass, 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 mass. Everyone had a mass. The equation did not give us a mass, so we can cancel it. Now, fill in our numbers. So I'm going to start over here. I'm just going to switch to blue because it's a lot of writing here. I'm going to start over here with gravity at 9.8. My initial height is here, 70 meters. That's my first term. Plus, and then this term is going to be 1/2 velocity squared. So if I check here at the beginning, my velocity there is 55 meters squared. I just want to talk about that symbol there. VO is the same as V initial. VO is pronounced V naught, and it's often the beginning or the start. You will see either term in Physics 11. So VI and VO are the same thing. All right, here's my equal sign lined up as close as I can. Now here, G 9.8. Now height final, I go over to my picture. There it is, 35 meters is how high up my little motorcycle is. And then my last one, 1/2 v squared, because I actually do not know my final. So that guy there, that's what I'm looking for. My next step would be to fill in, using my calculator, all of my numbers separately. So this one here turns out to be 68.6 plus this term is 55 squared divided by 2. So 1512.5 equals, this one is 343 plus 1/2 v squared. I'm just leaving that one alone. That's got my variable in it. I'm going to take care of it last. Okay, next, gather like terms. So these two here on this side of the equals, you want to put together in your calculator. So 2198.5 equals 343 plus 1/2 v squared. Next, we're going to subtract 343 to cancel it. So make sure that's a subtract and not a divide. Okay, so now we've got 1855.5 equals 1/2 v squared. Okay, to remove the half, if we're dividing on one side, when I bring it to the other, I want to multiply. So my equation there would be 3711 equals v squared. And again, last step, take the root for both of those, and you will find you get a velocity of 61 meters per second is equal to my final velocity. It's actually 60.89, I believe. So we're going to round that guy up. All right. Oh, rounded final answer right there. Sorry, 61 meters per second. Okay, and that's how you do the complicated equations. Now you should have no trouble finishing off your conservation of energy worksheet part 3, which is this one. I started you out with numbers 1 to 8, and you should now be able to go through all the rest of that worksheet with all of your math skills, and we will see you during tutorial time.